Sampling, the heart of research. Imagine baking a cake but only tasting a small slice to know if it's good. This is what sampling does in research. It lets us study a smaller, manageable group, our sample, to understand a larger group, our population. Good sampling ensures that our taste accurately reflects the entire cake. Why is this important? Because studying entire populations is often impossible or impractical. Imagine interviewing every single person in a country. Sampling makes research feasible while providing valuable insights. Effective sampling ensures our findings are representative of the whole population. It underpins the validity and reliability of our research, allowing us to generalize our findings with greater confidence. Probability sampling. Leaving it to chance. Probability sampling is like a lottery. Every member of the population has an equal chance of being selected. This randomness helps minimize bias and increase the generalizability of findings. One example is simple random sampling, where we randomly pick individuals from a list of the entire population. Think of drawing names out of a hat. Another type is stratified sampling. We first divide the population into subgroups or strata, based on characteristics like age or gender. Then, we randomly select individuals from each stratum, ensuring representation from all groups. Finally, systematic sampling involves selecting participants at regular intervals from a list. For instance, we might choose every fifth person on a patient list. Probability sampling is particularly useful in large-scale quantitative studies. Non-probability sampling when choice matters. In non-probability sampling, not everyone has an equal chance of being selected. Researchers handpick participants based on specific criteria or convenience. Convenience sampling is the most common type. It involves selecting readily available individuals like students in a classroom or shoppers at a mall. While easy and cost-effective, it's important to note that findings may not be generalizable to the wider population. Quota sampling aims for proportional representation of different subgroups. For example, a researcher studying consumer preferences might aim to interview a specific number of men and women within different age groups. Lastly, purposive sampling involves selecting participants based on specific expertise or experiences. This is common in qualitative research where in-depth understanding is key. Determining sample size, the HO calculator. Choosing the right sample size is crucial for reliable research. Too small, and our findings might not reflect the population. Too large, and we risk wasting resources. The World Health Organization provides a handy calculator to help determine the appropriate sample size. This calculator considers factors like the population size, desired confidence level, and margin of error. The confidence level indicates how confident we want to be that our sample accurately reflects the population, while the margin of error represents the acceptable range of variation. By inputting these values, the calculator provides a recommended sample size. This tool simplifies a complex calculation, ensuring our research is statistically sound. Power calculations go hand in hand with sample size determination. They help us determine the minimum sample size needed to detect a statistically significant effect if one truly exists. In simpler terms, it tells us how likely our study is to find a real difference or relationship. A study with low power might miss important effects, leading to inaccurate conclusions. On the other hand, a high-powered study increases our chances of detecting even small but meaningful differences. Factors influencing power include the effect size, significance level, also known as alpha, and sample size. Using statistical software or online calculators, we can perform power calculations to determine the optimal sample size for our research question. Univariate analysis is like looking at ingredients individually before baking a cake. It involves describing and summarizing a single variable at a time, such as age, gender, or test scores. We use descriptive statistics like mean, median, mode, range, and standard deviation to understand the distribution of our data. For example, if we're studying the age of participants in a study, univariate analysis would tell us the average age, the youngest and oldest participant, and how spread out the ages are. Visual tools like histograms and bar charts help us visualize the data and identify any patterns or outliers. Univariate analysis forms the foundation for more complex statistical analyses. Multivariate analysis is about understanding the cake as a whole, how different ingredients interact. It examines relationships between multiple variables simultaneously. For instance, we might explore how age, gender, and income level influence purchasing decisions. Common techniques include correlation analysis, which measures the strength and direction of the relationship between two variables, and regression analysis, which helps us predict one variable based on others. Multivariate analysis allows for a more nuanced understanding of complex phenomena. By uncovering hidden patterns and interactions, multivariate analysis provides a richer understanding of the factors at play. Just as a cake requires the right ingredients and baking process, research demands rigor in both sampling and analysis. Proper sampling ensures our findings reflect the population, while appropriate analysis techniques help us extract meaningful insights from the data. When sampling is flawed, our findings may not accurately represent the population, leading to misleading conclusions. Similarly, incorrect or inappropriate statistical analysis can result in erroneous interpretations of the data. By adhering to best practices in both sampling and analysis, we strengthen the validity and reliability of our research, contributing to a more robust and trustworthy body of knowledge. Mastering sampling and analysis is an ongoing journey. As beginner researchers, understanding these fundamental concepts is crucial for conducting meaningful and impactful research. By embracing these principles, we pave the way for discoveries that shape our understanding of the world around us.